All right, guys. Moving on to the second type of transformation that we are going to cover. We just finished going over translations, where translations is a slide of a figure from across the coordinate grid. Today, we're going to be talking about what are known as reflections. Okay. So now, a reflection is a flip over a line called the line of reflection. Okay. So it's a flip over a line called the line of reflection. So like right here, so here's the image right here. So like right here, here's our pre-image, triangle ABC. We have this line right here. This is our line of reflection. And what's happening is that whatever the image is being reflected on the opposite side to make our new image. Okay? So what happens is that each point that's on the image, they are the same distance from the line of reflection. Okay, so what we're going to be doing here is we're going to be figuring out how far apart the image and pre-image are from the line of reflection. Okay, so they're each distance. So like the distance however far B is from the line B prime is the same. However far A is from the line A prime is, as well as C and C prime. They're the same. They're the same measure. Okay. So, possible lines of reflection. And so the most popular ones we're going to be using are reflecting over the x-axis and the y-axis. Oops, x is the x-axis. And then, of course, we can reflect over other types of vertical and horizontal lines. So, for example, like you can have vertical, horizontal lines. Horizontal lines would be written in the form of y equals some number, and vertical lines are written as x equals some number. So we'll get into those examples here in a little bit. And then, of course, we have diagonal lines that we can reflect over. So now these lines are going to be y equals x and y equals negative x. But we will tackle those type of reflections here in a bit. Okay, so first let's do a couple of easy ones. So the first one wants us to reflect triangle ABC with points A is at -4, 2, B is at 4, 7, and C is at 5, 1, and we're going to reflect over the x-axis. So first let's label our points. So -4, 1, 2, 3, 4, -4, 2. So here's A. B is at 4, 7. 1, 2, 3, 4, 7. 1, 2, 3, 4, 5, 6, 7. And C is at 5, 1. 1, 2, 3, 4, 5, 1. So here's A, here's B, and here's C. Okay, so the way this is going to work is what we're going to need to do is we need to find how far apart the points are from the line of reflection. So the line of reflection is going to be the x-axis. So of course we need to know which of the axes is the x-axis. So the one that's going up and down, that's the y-axis. The one going left and right is the x-axis. So right here, this is the line of reflection. So what we need to do is we're just going to count how far apart each point is from the line, and then we're going to trace that same amount in the opposite direction. So A is 1, 2 points from the line, so that means that A prime must also be 2 points away from the line, but in the opposite direction. So right here, this has to be A prime, because right here that's 1, 2 units away, so this one's also 1, 2 units away. So B is 7 units away because it's 7. So if I were to count 1, 2, 3, 4, 5, 6, 7. So then I have to count the other way. 1, 2, 3, 4, 5, 6, 7. So right here, this is going to be B prime. And then C is only 1 unit away because the y coordinate is 1, so 1. So this is C prime. So then, of course, if I connect the dots, we'll be able to see the actual flip of our new image. Okay? So, of course, we want to get those coordinates. So the A prime is at -4, -2. So -4, -2. B is at 4, -7. And C is at 5, -1. Okay, so that is the simple way of reflecting the image. Now, if you're reflecting over the x-axis, there is kind of like a little trick that you can do, is if you're flipping over the x-axis, on your coordinates, the x-coordinate is going to stay the same. So see how it's -4, -4 for A and A prime, 4, +4 for B, 5, 5 for C and C prime. But the y-coordinate, all you have to do is just change its sign. If it's positive, turn it negative. If it's negative, turn it positive. Okay? So like right here, y was at 2. So then over here, y is at -2. For B, B is at +7, -7. C is at +1, -1. So that could save you some time doing on the x-axis. If you're doing the reflecting, of course, if you want to do the counting, that's perfectly fine as well. And then right now you're going to see how the same thing works for the y-axis. So for number 2, rectangle PQRS with vertices at P12, Q25, R83, and S70. We're going to reflect over the y-axis this time. So the y-axis is the one going up and down. So it's going to be reflecting from one side to the other. All right, so let's plot the points. So P is at 1, 2. So 1, 2. Q is at 2, 5. So 2, 1, 2, 3, 4, 5. R is at 8, 3. 1, 2, 3, 4, 5, 6, 7, 8, 3. 1, 2, 3. And S is at 7, 0. 7, 0. There we go. So here's my rectangle. So this is P, this is Q, this is R, and this is S. So we need to once again count how far apart Q, P, R, and S are from the y-axis, because this is the maybe you guys can see this a little better. Okay. There you go. All right, so P is 1 unit away, so that means that P prime has to be 1 unit on the other side of the y-axis. So right here, so this is P prime. Q is 2 units, so it has to be on this side 2 units. 1, 2. Q prime. R is 8 units, so on the other side it has to be 8 units. And then S is 7 units, so it has to be on the other side 7 units. And here is the image. And there you go. There's your reflection over the y-axis. So of course, doing the counting is definitely the easiest setup. But of course, kind of like what we did over here, when you reflected over the x-axis, the x stayed the same, and you changed the sign of the y. You're going to do the same thing over here. but this time the y is going to stay the same, and you're going to change the x's. So this 1, 2, 8, and 7 are going to become negatives, and the 2, 5, 3, and 0 are going to stay, they're going to stay the same. So P is at -1, 2, Q is at -2, 5, R is at -8, 3, and S prime is at -7, 0. And there you go. Not too difficult, but it can get a little frustrating. So definitely doing the counting can help. All right, so let me see. I think I might be able to do one more. How much time I got left? You know what? No, I'll do the next one on the next video. All right, so continuing on, kind of ran out of time on the other video. So trapezoid, FGI with vertices at -5, -2. So -5, -2, 1, 2, 3, 4, 5, -2. There's F. G at -2, -2. H at 0, -6. 1, 2, 3, 4, 5, 6. And -8, -6. So here's F, here's G, here's H, and here's I. So let me draw the figure so you can see the trapezoid. All right, so reflecting over the y-axis, so right here, over the y-axis, so we're going to be flipping to this side over here. So count how far each one is. So G is 2, so the new G is right there, G prime. F is at 5, so 5 over here, 1, 2, 3, 4, 5. I is at -8, so it's going to be 8 this way, so it's over here. Now with H, I did skip H because H is actually on the axis, okay? So if it's on the axis, it actually has a distance of 0, which means it's gonna stay at the same spot. It's not gonna move. It's actually on the line. So what it's gonna look like if I connect the dots is like the following. There we go. Just like that. So right here, so this is G prime, this is F prime, this is I prime, and then right here this is also H prime. H and H prime are the same coordinate. So if you're going to do the rule like we did on this last one, since we're reflecting over the y-axis, that all we're going to do is change the sign of the x's. When you get to the H one, because it's 0, since 0 is neither positive nor negative, you can't change its sign, so it just stays 0. So F prime is now +5, -2. G prime is +2, -2. H is still 0, -6. And I prime is +8, -6. So it's being reflected, and since it's on the line, the H and H prime stay at the same point. All right. Finally, the rhombus reflecting over the x-axis. So rhombus W, X, Y, Z. W is at -2, -4, which is right here. X is at 1, -2, which is right here. Y is at 4, -4. 1, 2, 3, 4. 1, 2, 3, 4. So Let me just make sure I did it right. 1, 2, 3, 4. 1, 2, 3, 4. Yeah. And then z is at 1, negative 6. 1, 2, 3, 4, 5, 6. Right here. All right. So this is w. This is x. This is y. And that's z. Okay. So this one we're reflecting over the x-axis. So it's gonna flip over here to this top part. So it should be a nice reflection because there are no points on the line. So just count the distance. So x is 2 away, so the new x is also 2 away. Y is 4 away, so the new y is also 4 away. 1, 2, 3, 4. W is also 4 away. 1, 2, 3, 4. So it's 1, 2, 3, 4. And then z is 6 away, so it's also 6 away. 1, 2, 3, 4, 5, 6. So this is x prime, this is y prime, this is w prime, and then this is z prime. So that one was easy because I didn't have to worry about the point being on the line. So of course, since we're reflecting over the x, then the x coordinate is going to stay the same, but the y's are going to change. So I'm going to have to change the signs of the y's. So w prime is negative 2, positive 4. X prime is 1, positive 2. Y is 4, 4. And z prime is 1, 6. So all we have to do is just change the signs. Alright guys, so continuing on, now we're going to be looking at some reflections that are done over lines that are not the x and y axis. Instead, you're going to be given like x is equal to some number and y is equal to another number. So the one thing you do need to remember is that if you're given an equation like x equals something, that means that your line of reflection is actually a vertical line. It's a line that goes up and down. And if you're given a line of reflection of a y equals a number, that means that your line is horizontal, so it goes left and right. So I know these videos have been quite long. I'm going to try to save some time. I already drew in the points that they're given to us, so that way I can try to make these last couple of videos as short as possible. So it says triangle. JKL with vertices at J at 1, negative 1, K 2, 3, and L 3, negative 2. It wants to reflect over the line x equals 4. So it's x equals 4. So what that means is that it's going to be a vertical line. So to find where the line is, you're going to go to x equals 4, which is right here. And then all you have to do is just kind of like imagine this line right here. And that's going to be your line of reflection. So it kind of works the same way as we did with the x and y axis. All you're going to do is just count the distance each point is from that line, and then all you have to do is just put the point on the opposite side, that same direction. So it doesn't matter which one you want to start with. If you want to do k is 2 units, so 2 units this way. Here's k prime. L is 1 unit, so over here this is L prime, and J is 1, 2, 3 units, so 1, 2, 3 units. So here is J prime. And there is your reflection over x equals 4. So then once you're done, all you have to do is just get those coordinates. So let's see, so K prime is at 1, 2, 3, 4, 5, 6, 1, 2, 3, 6, 3. L prime is at 1, 2, 3, 4, 5, negative 2. And J is at 7, -1. There you go. So once again, you should see that because we're reflecting over the x-axis, the graph is moving left and right and not up and down. So the y-coordinates should be the same, and the x-coordinates are changed by the difference of how far away they are. So like 1 is 3 away from 4, so another 3 is 7. 2 is 2 away from 4, so another 2 is 6. 3 is 1 from 4, so another 1 is 5. Alright, so let's take a look at the next one. So x equals -1. So x equals -1 is right here. Here's -1. So this is going to be my line of reflection right here. Alright, so same thing. Right away, if you want to save yourself some time, once again, we're going left and right, so the y's are not going to change. So you can just go ahead and fill out all of the y coordinates. So r, it's going to stay 3, s is going to stay 4, t is going to stay -1, and u is going to stay -2. And then all we have to do is just get the other ones. So r is 1 unit, so here's r prime. S is 1, 2, 3, 4, 5, 6. So 6 the other way. 1, 2, 3, 4, 5, 6. U is 2, so 1, 2. And T is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And there it is. So this is R prime, S prime, U prime, and T prime. There we go. So then all we have to do is just get the x coordinates. So R is at -2. S is at -7. T is at -8, and U is at 1, 2, -3. And there you are. Real simple. So not bad. Just do a little bit of counting. You can also do a little bit of math if you want to, but doing the counting is definitely going to be the easy setup. So remember that if it's an x equals, the y's are going to be the same as the originals. All right, so oops, I forgot to label these. So C, so this is C, D, E, and F. Okay, there you go. All right, so this time it wants to reflect over y equals 2. So now this time it's a y equals equation. So anytime you have this y equals, that means that you're going to have a horizontal line of reflection. So you're going to go to y equals +2, which is right here, and then just go ahead and just trace out your line of reflection. It's right here. There we go. So now we're going to do the same thing, except this time we're going up and down. We're going to count the distance, and it's going to flip over the other side. And then once again, because we're going up and down, this time the x coordinates are not going to change. So you can save yourself some time. Just copy those x coordinates. Those are going to be the same. Whoops. It's 4. There you go. Copy the x coordinates, and the ones that are going to change are going to be the y's. So E is 1 unit, so 1 unit up. So here's E prime. D is 2 units, so 2 units up. Here's D prime. C is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Here's C prime. And F is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And here's F prime. Connect the dots. And there's your reflection. So all we have to do is get the y coordinates. So let's start with C. C is at 8. D is at 1, 2, 3, 4. E is at 1, 2, 3. And F is at 7. And there are your coordinates. Alright, last one for this one. Triangle MNP, vertices -6, -8, -1, -6, and -2, -8. It wants us to reflect over y equals -5. So at -5, that's right, 1, 2, 3, 4, 5. So here's -5. So once again, it's a horizontal line. So here's the line of reflection. Once again, the x's are going to stay the same, so you can just go ahead and just copy the x's. So -6, -1, -2. And then all we're going to do is we're going to change the y's. So n is 1 unit from the line, so n prime is 1 unit up. P is 1, 2, 3, so 1, 2, 3. It's P prime, and M is 1, 2, 3 also, so 1, 2, 3. And this is M prime. So there's the reflection right there. So let's see, let's get the y coordinates. So n is at -4, P is at -2, and M is also at -2. Whoops. Yes, I'm sorry. That's right. Okay, so real simple. Draw your line and then just count the distance. All right, guys. So then the last type of line of reflection we're going to be talking about are the diagonal lines. So the diagonal lines are going to be represented by y equals x or y equals -x. So the way y equals x and -x look like, it's this diagonal line that follows straight through. Trying to do this as neat as possible. Through the coordinate grid, cutting it nice and even across the grid, going diagonally. So the way it's going to work, it's not really going to be like counting the distance, but what it's going to do instead is all we're going to do is we're going to manipulate the original coordinates. So like x is at -5, -2, y is at -3, 4, z is at -1, 1. So anytime you're reflecting over y equals x, all we're going to do is take these two coordinates and we're going to swap them. So originally x is -5, -2, so x prime would be -2, -5. All I did was I switched the two. So now the new x coordinate is -2, the new y coordinate is -5. Real simple. And then of course we're going to do the same thing for the other two. We're going to swap -3 and 4 for y prime. So 4, -3. And then the same thing with z. We're going to swap -1 and 1. So 1, -1. And there it is. So once you swap the two x and y's, now you can go ahead and plot the points. So x prime is at -2, -5. So -2, 1, 2, 3, 4, 5. So right here, this is x prime. I'm going to wait to label it. 4, -3. So 1, 2, 3, 4. 1, 2, 3. And then z is at 1, -1, which is right here. So here's the reflection. So this is x prime, this is y prime, and this is z prime. So very simple, just it's a lot easier. Like I said, it's a lot easier than it looks. All you have to do is just swap the two. So for the next example, not that one. This one, here we go. I had to do another one because I messed up originally when I did number 9. So the line is y equals x again. So y equals x is the diagonal line that cuts across. I'm trying to be a little bit more neat. And then all you have to do, once again, is swap the x and y coordinates for g, h, I, and j. So g is 2, -1, so g prime is -1, 2. H is 7, -1, so h prime is 1, -1, 7. I is 7, -4, so I prime is -4, 7. J is 2, -4, so j prime is -4, 2. Very simple. So all you have to do is go ahead and plot these points. So -1, 2, this is G prime, -1, 7, that's H prime, so this is G prime, this is H prime, -4, 7, 1, 2, 3, 4, 7, and then -4, 1, 2, 3, 4, 2. And this is J prime, and this is I prime. And there's your reflection. All right, so real simple when it comes to reflecting over y equals x. All you have to do is just swap the two. Now, for the next type of diagonal is y equals -x, which is basically the same thing, except this time instead of the line coming right here across, it's going to be going in this direction. I'm try to be as neat as possible. There you go. All right, so it kind of works the same way where we're going to swap the two. However, there is a catch. Once you swap them, you do need to change the signs, which means if the original point was negative, you're going to make it positive. If the original point was positive, you're going to make it negative. So the original A is -1, +3. So that means when I swap it, the 3 is going to come first, but 3 is now going to be negative. -1 will be second, but now it'll be +1. So they do switch. So here's the 3, here's the 1, but the signs change. So this is now a +1, this is now a -3. And then of course if you have a 0, well 0 does not have a sign, so that means that 0 stays the same. But this 6 will turn into a -6. So for B prime it'll be -6, 0. For C prime it's going to be -5, -3. And for D prime it's going to be -2, -2. And then once you're done, all we have to do is now just plot those points. So -3, 1, 2, 3, 1. So there's A. -6, 0. There's B. This is A, this is B primes. C is -5, 1, 2, 3, 4, 5. -3, 1, 2, 3. There's C prime. And then D is -2, -2. And there's the reflection right there. So not that much difference from the other one. Just now we are switching and changing the signs. So then the last example, same thing. We're reflecting over y equals -x. So y equals -x is going this way. There we go. Alright, so let's go ahead and change the signs and swap. So S is -1, -6. So it's going to swap to a +6, +1. T is at 0, -3. So T prime will swap to a 3, 0. And then U is at 3, -4. So it's going to swap to a +4, -3. There we go. Alright, so then all we have to do once again is just plot those points. So S prime is at 6, 1. So here's S prime. T prime is at 3, 0. So 3 zeros right here. And then U prime is at 4, -3, so it's right here. That's U prime. And then there's your reflection. Okay? So just remember that. Let's see if we can get both of these in the shot. Okay. So if you're going y equals x, all you have to do is just swap the two. Just swap them. If you're doing y equals -x, you swap the two, but you have to change their signs. So if it's negative, turn it positive. If it's positive, turn it negative. If they're zeros, leave them alone.